Hello everyone, I will be doing problem 3.44 today. Now in problem 3.44 we have a charge plus Q that is distributed uniformly along the z-axis going from negative A to positive A. So we could show this here, and then another arrow coming from this direction. And this has, since we know it is a plus charge Q, we know that lambda is equal to Q over this length of 2A. And we're trying to find the potential, the electric potential at any point R. So when we have this R vector, we know that this angle would be theta because it's in this is in the z direction. And we're also going to have this angle, which is going to be pi minus theta. So for z greater than 0, alpha is equal to theta. But for z less than 0, alpha is going to be pi minus 0, or pi minus theta rather. And this alpha comes from the potential equation for when we use multi-pole expansion. The sum from n is equal to 0 to infinity, 1 over Rn plus 1, integrating R prime n Pn cosine alpha times rho of R prime d tau prime. These prime vectors are coming from our source, and this is a Legendre polynomial for cosine of alpha. So since we have two different alphas, we can split this up into two equations, or two integrals rather. Still summing up from n is equal to 0 to infinity, Rn plus 1. So we're going to integrate from negative a to 0 z prime, the absolute value of z prime to the n, because n is less than 0 for this region, Pn cosine of pi minus theta times lambda d tau, and this is going to be plus 0 to a rather, z prime to the n, Pn cosine theta, lambda dz prime. So we know that cosine pi minus theta is equal to negative cosine theta, and whenever we have a negative inside of this Legendre polynomial, we know that it will be negative 1 to the n Pn times this Legendre polynomial. So we can bring everything back into this equation. One over 4 pi epsilon naught, summing n is equal to 0 to infinity, 1 over Rn plus 1 times this integral from negative a to 0, z prime to the n times negative 1 to the n Pn cosine theta lambda d tau plus 0 to a z prime n p n cosine theta lambda dz. Or this should not be a d tau. Either these both should be dz prime, right? Now we can take some values out of these integrals. We can take this pn cosine theta and lambda out of both of these integrals. Leaving us with negative a to 0, z prime, the absolute value of z prime to the n, negative 1 n dz prime, plus 0, the integral from 0 to a, z prime n dz prime. Now, this absolute value of z prime n times negative 1 to the m can be written as z prime n times negative 1 to the n times the other negative 1 to the n, which just leaves us with z prime to the n, which means we can combine this integral just write it all out here, negative a to 0, z prime to the n dz prime, plus 0 to a, z prime to the n dz prime would be equal to negative a to a, z prime dz to the n, rather. And when we integrate this, we're going to get 1 over n plus 1 z prime n plus 1 from negative a to a, and then this is going to leave us with 1 over n plus 1 times an plus 1 minus negative an plus 1. So, and when we look at this, we know that when n is even, we know that for 0 a for when n is even, these will add together and will give us 2an plus 1 over n plus 1, and when n is odd, these will subtract each other and give us 0. So we could put everything back into our multipole expansion, 1 over 4 pi epsilon naught, now summing from 0 to 4, etc., to infinity, 1 over n plus 1, and now we can plug in this lambda that we had previously, where lambda is equal to q over 2a, times pn cosine theta times what we evaluated for this integral, 2an plus 1 over n plus 1. We can explicitly write this as 1 over 4 pi epsilon naught times 1 over r, and these 2's will cancel out. 1 over r, q over a, p0 cosine theta, times a for the first term, plus 1 over r cubed, q over a, p2 cosine theta, a cubed over 3, plus 1 over r to the 5th, q over a, p4 cosine theta, times a to the 5th over 5, plus the other terms. Now we can actually take a q over r out of this expression, leaving us with 1, because p0 of cosine is just 1, where these a's are going to cancel, these a's are going to cancel, and these a's are also going to cancel for every term. And this leaves us with 1 plus one-third a over r squared p2 cosine theta plus 1/5 a over r to the 4th p4 cosine theta plus extra terms. And that's how you get the multipole expansion for this uniformly charged distribution along the z-axis from -a to a. Thank you.